Right, we're going to be continuing our work with infinite series, and remember we're just trying to find the sum of a sequence where all of the terms are being added together. If a sequence is a geometric series, there's a special way that we can find the sum. At the end of this lesson, you'll be able to find the sum of a geometric series. All right, first of all, let's look at, I have two formulas for a geometric series. We have, this one goes the sum, please remember that this means the sum. So when you see that, it's just asking you to add the numbers together in the sequence of when I start at the first term and go to infinity. And it's a times r to the n minus 1, which is r is a constant ratio. Or we could have it written as we're starting at the 0th term, which doesn't make too much sense. We have a times r to the n. These actually are formulas that you learned from Algebra 2. You probably did not use the summation notation, I'm not sure, but maybe you did. An example of a geometric series, or a couple ones, would be 2, 4, 8, 16, because notice each time you're multiplying by a constant ratio, which would be 2. Another one would be 10, 15, 10, 50, 250, because each time we're multiplying by 50, so the constant ratio, or the r, would be 50. And then another one would be 5, negative 15, 45, because on this one, we're just multiplying by negative 3 every time, so our r would be negative 3. So if you notice, sometimes you're going to have to, on these, start writing the terms of the sequence, and then you'll be able to decide if it's geometric or not, and then if it is, then you can use this formula. A is going to stand for the first term. So we want that first term of the sequence, and then the r is going to stand for that constant ratio. What are you multiplying by every time to get the next term? Okay, so if you can identify those two things, and it is a geometric series, this is how you find that sum. We don't have to do partial sums. We can just use this formula to get it. All right, so let's look at some examples. This one asks us to find the sum of the sigma notation is the sum. It's going from 2 to infinity of 1 to the n over 4 to the n. All right, what we are going to do, since this sum, it actually starts at 2, I'm just going to start writing out the first few terms of the sequence. So I have to start at n equals 2. So if I plug 2 in here, I am going to get 1/16. If I plugged 3 in, I'm going to get 1 over 64. If I plugged 4 in, I'm going to get 1 over 256. And remember, since it's asking us to find the sum, we have the terms of the sequence. It's asking us to add the terms of the sequence together. Okay? It's obvious that this is a geometric sequence because each time I'm multiplying by 1/4, so I know without doing anything with this that my r is going to equal 1/4. But if I'd like to determine this mathematically, since they both have an n power, you can rewrite this as 1/4 raised to the n power, and as soon as I do that, I notice that this is my ratio. If we have something raised to the n power, that's always going to be my ratio. So if I would like to get the sum from here, I'm just going to put s equals, remember it was a over 1 minus r. My first term was 1/16, and then 1 minus, the common ratio was 1/4, and when I figure that out, I'll get 1/16 over 3/4. I'll multiply by the reciprocal, so I'll get 1/16 times 4/3, and that will give me 1/12 for my sum. So if we added all the terms of this sequence up, we would end up getting 1/12 as an answer. All right, the next one, it says to find the sum. Again, this one is starting at n equals 0. We'll get negative 1 to the n times 5 over 4 to the n. Now, I'm guessing that this is geometric because I have two things raised to the n power. But if we were not sure, what we could do is just go ahead and start listing the terms of the sequence. If I plugged in 0, because it says to start at n equals 0, negative 1 to the 0 would be 1 times 5/4, so my first term is going to be 5/4. My second term, if I plugged in 1, I'll get negative 5/4. If I plugged in 2, I'm going to get 5/16. And please remember, since it's asking us to find the sum, we're just going to add all of those terms together. I can tell on this one that each time we are multiplying by negative 1/4 to get an answer. Did I do that correctly? Actually, this should be 5 because 4 to the 0 was 1. So we should have 5 plus negative 5/4 plus 5/16. All right, so when we do that, I can just see from looking at this pattern that my r is going to be negative 1/4, but I would like to show you mathematically how we would get that as well. Since these are both n's, I'm actually, just like I did up here, going to write those as a fraction. and then the times 5 would just hang out for the ride. So then once again, whatever is being raised to the nth power, that's going to be my ratio. And then again, I usually don't like to use the formula to get the first term. I actually like to plug the numbers, whatever my first n is, in to get that first term. You're more likely to get the right answer. So my sum is going to equal a, which is the first term, which is 5 over 1 minus the constant ratio, which is negative 1/4. And then this will be 5 over 5/4, so I'll multiply by the reciprocal, so I'll get 5 times 4/5, so my sum is equal to 4, which means if I were to add all of the terms of the sequence together, I would end up getting an answer of 4. All right, we are flipping over on the other page to example 6. I had it on the second page and then decided it really should go on the first page with the geometric series. You will notice that we have two things raised to the n power. Actually down here it's an n plus 1 power, so it's looking like it's going to be a geometric series, so we're just going to test it out. If I plugged in, remember we're going to start with n equals 0, so if I plug in 0, we will get 1 over 7. The next term of my sequence, if I plugged in 1, I'll get 2 over 49. If I plugged in 2, we'll get 4 over I'm trying to think what that is. 49 times 7, 363, 28, 343. Good. All right, and dot, dot, dot. We keep going. Remember, when we're finding the sum, we would like to add those terms together. And I do notice it looks like it is geometric because it looks like every time I'm multiplying by 2/7 to get my next answer. So I'm believing that my common ratio is going to be 2/7. We are going to prove that mathematically, however. So what we are going to do is, actually, I'm going to break this up down here into 7 to the n times 7 to the 1, because then I can put the 2 and the 7 together because they're both in n power. So this is going to be 2/7 to the n power, and then since the 7 is left over down beneath, it's going to be times 1/7. So that's my new formula. It is a geometric series because the ratio is 2/7. And again, when I go to get the first term, I usually actually like to find it myself instead of trusting the formula. So I'm going to get the sum is equal to a, which is the first term, is 1/7 over 1 minus the common ratio. The common ratio is 2/7. So this will be 1/7 over 5/7. So I'll get 1/7 times 7/5. My sum will equal 1/5. All right, in example 7, find the sum. We have 3 over 4 to the n plus 5 to the n to the negative 1. One thing that I'm going to do on this one, because we have a plus sign, we can treat these as two separate series. So I'm going to actually find 3 over 4 to the n plus 5 to the negative n, and I was naughty on this one because I did not put some limits. This should be at n equals 0, and this will go to infinity. So for each of these, we'll have n equals 0, and n equals infinity, n equals 0, and n equals infinity. So we basically have two problems in one here. I am going to go ahead and start writing my term numbers on this one. So I'm going to have the first term, if I plugged in 0, I'm going to get 3. If I plugged in 1 for my next term, I'll get 3/4. If I plugged in 2 for my next one, I'll get 3/16, and then we could obviously keep going. It looks like I'm multiplying by 1/4 every time, so I'm going to say that my common ratio is 1/4. I will prove it mathematically. Since there's only one thing that has an n power, and it's by itself and it's on the bottom, I'm going to actually put a 1 up there, so this would be 1/4 to the n power, and then that 3 is hanging out. So that's what it would look like. The ratio is definitely 1/4 to get the first term, although it is 3 in this case. I generally just like to plug it in and figure it out. So, and I'm going to keep that like it is for a second, and then we'll finish it up. Okay, this one, if I have 5 to the negative n, I'm going to rewrite this as 1 over 5 to the n. It just makes more sense to me. So the first term, if I plug in 0, I would get 1. If I plug in 1, I'll get 1/5. If I plug in 2, I'll get 1/25. And so notice we're adding those terms together, and it does look like on this one the ratio is 1/5. And to rewrite this so that it is an actual geometric series, it would be 1/5 to the n power. So we do have two geometric series, and now we're going to go ahead and find the sum. So the first one, again, will be a over 1 minus r. So a is 3 over 1 minus the common ratio. That will be 3 over 3/4, which is 3 times 4/3, which is 4, and then plus a over 1 minus r for the second one. A would be 1 over 1 minus the ratio, which would be 1/5. So this will be 1 divided by 4/5, which will be 1 times 5/4, which will be 4 plus 5/4. So 4 plus 5/4 would be 5 1/4. So my sum in this problem would equal 5 1/4. So hopefully now you are familiar with finding the sum of a geometric series.